Okay, this is quite an interesting substitution question, right? We're going to learn something new here. So the substitution we're going to use, we're going to say this denominator here, x squared minus 1, we're going to call it u, okay? And the first thing you'll be perhaps trying to do is to establish what x cubed is going to be, yeah? All right, you're going to think, well, how can I get x cubed from here? Okay, now if you try and do it, okay, then it's going to be hard work, it's going to be laborious, and it's not going to look particularly nice, okay, and you're going to go wrong, all right? So the temptation might be for you to think, oh, well, okay, I've got this, so let's rewrite this and as u plus 1 equals to x squared, because I've got the minus 1, take it over, becomes plus 1. And then you think, okay, well, I need x cubed, so perhaps let's work out what x is and then cube it. The trouble with that is, if you work out what x is, you're going to have to square root, aren't you? Yeah, because x squared is this. You're going to have to square root all of that. And remember as well, when you square root, you've got to put plus or minus there, because there's two options. And then you've got to somehow cube it. It's going to get messy, okay? So don't use that approach, and just take your time and things will work out. So let's forget about that x cubed for a minute, all right? Let's see if we can replace the dx, okay, with the du. Now we can differentiate, can't we? Okay, that's easily, we can do that. So du by dx, okay, u with respect to x. Well, differentiate this here, you get, bring the power down to 2x. Minus 1 becomes 0. That means then, okay, what you could do is take that dx up that side, so you'd have du is equal to 2x dx, okay? But remember, I want dx, okay? I want to work out what dx is because I want to replace it. So in this case here, to work out what dx is, I need to get rid of that 2x, take it over the other side and divide. So that means du by 2x is equal to dx, okay? Again, you might be starting to get a bit worried because there's an x here. It's like, how on earth are you meant to deal with this? But you just go with it. So we couldn't really work out what x cubed was from here because we got into a mess. We could work out what dx is, okay, but it's involving x. Let's just go for the integral now. Let's just go for the substitution. Let's do what we can, right? So x cubed, I don't know what that is. Okay, it's messy if I do it this way, so I'm just going to leave it as x cubed. Okay. On the bottom then, x squared minus 1, well, that becomes u, yeah? But then my dx gets replaced by this, du over 2x. So I've got du over 2x. Now, look at this here and see if you can find the direction forward from this. Okay? You might spot to start with that the 2 on the bottom can be taken outside because it's like a half, and you can. I would do that actually. Okay, half is the integral of x cubed over. Well, then I've got u times x, then haven't I? du. Can you see something else we can do then? I'm sure you can see then that perhaps we can cancel these x's, yeah? So that x cancels with that cubed to become a squared, okay? X cubed divided by x is x squared, and then you just need to appreciate then, x squared, well, I can figure out what x squared is, yeah? So since u is equal to x squared minus 1, u plus 1 will equal to x squared, okay? So now I can get rid of that x term there, because it's x squared, I can replace it with u plus 1. So I end up with that. Okay. Then I need to integrate this. Okay, and it's actually quite straightforward integration. When you have a number, you know, it doesn't have to be 2 terms, it could be 3 terms, it could be 4 terms, it doesn't matter. However many terms on the top, if you're just dividing it by a single term, okay, instead of thinking I've got to add them up, then divide them by u, I can actually divide them all individually. Okay, so I'd have u divided by u, so if I divide that by that, and then I'll have the 1 divided by u, and there's a plus in between them. So I can divide them separately. Then I get, well, u over u is 1. And 1, let's leave it as 1 over u, because if you think back then how to integrate this, okay, of course, when you've got linear on the bottom, we've got to use ln. So this becomes 1/2. 1 becomes u, and 1 over u becomes ln u plus c. And all you've got to do then to finish off is to put in what u is. So u was x squared minus 1 plus ln of u, so x squared minus 1 there. Okay, times by half at the front, and then plus your constant.